One of the things I do on this channel is I teach and give tips on soldering for electronics. And many or even most who are learning this skill are doing so because of an interest in electronics in general. So in this video, I'm going to show you the things that are the most essential when beginning to dive into analog electronics. And I specify analog electronics because it's a different beast than digital electronics, and actually the backbone thereof. Digital is fundamentally analog. We use the word analog because at any point in the circuit, the voltage is analog for the information being processed. It's analogous. In audio processing, the voltage is analogous to the sound wave. In LED drivers, the voltage, or even the current, depending on the type of driver, is analogous to LED brightness. And I want to briefly contrast with digital electronics so a distinction is really clear. Digital uses discrete voltage levels to represent discrete states. This can have any number of levels, but binary is by far the most common because it's simple, efficient, and the most immune to noise. But even this is still analog under the hood because each digital state is represented by a voltage level, which is analogous to a digit. So even if your interest is in digital electronics, a proficiency in analog electronics is fundamental to understanding how it all works. This video is going to focus entirely on what you need to begin developing and experimenting with analog electronics. So there won't be any mention of any digital platforms or development boards or anything like that. But all of this is also applicable to digital electronics, being that analog is the foundation to digital. And real quick, remember to hit that like and subscribe button if you're enjoying the video so far. It helps out the channel a ton. Number one is a bench power supply. And this is number one because it's really number one. You can't develop any electronics without being able to power them. And it doesn't have to be anything expensive. You can start pretty cheap, but never buy anything dirt cheap. If you go dirt cheap, you just end up getting junk that isn't even worth the money you did spend on it. I do recommend linear power supplies because their power output is much smoother and less noisy than switch mode power supplies. However, they are more expensive because they have bigger transformers in them and don't run as efficiently. You want a power supply where you can set a specific voltage and a current limit, as well as having a display to show you your settings and real-time power usage. You also want the output to be isolated from ground. If it has a separate third post for ground, you know that the positive and negative terminals are isolated, and you have the option for grounding if you want or need it, but you most often won't. Number two, digital multimeter. This is what you'll use to do your simple measurements. Resistance, continuity, DC voltage, basic diode tests, and some can even measure frequency and capacitance. These are especially useful for troubleshooting circuits that you have on PCBs. That's where mine see the most use, especially when repairing something that I didn't design. But this is an essential tool performing functions which you can't get by without, even if you aren't reaching for it every single day for what you do. And this is something else that you can get something on the cheap that will do a good job, though I would be wary of the calibration drifting more over time versus the better brands like Fluke or Klein. I recommend getting something auto-ranging, which most are these days, and look for these features at a minimum. If it doesn't even have one of these, don't consider it. DC voltage, AC voltage, DC current, AC current, never mind the fact that the C stands for current in both of those abbreviations, resistance, continuity, diode test, and a minimum of millivolt milliamp precision. Additionally, look for these features according to what you think you will need. Temperature probe, capacitance, nanofarad precision at least, but picofarad precision would be better, frequency, and a clamp type current probe. Many refer to those as amp clamps. At the end of the day, you can't have too many multimeters, but make sure you have all the metering capabilities that you do need, whether it's all in one unit or spread across a few different ones. Number three, oscilloscope. And you are going to use this one every day. You can't get very far without one. What it does is it plots voltage over time, and you can set the time period and voltage sensitivity. This is literally your window into what's going on inside your circuits. Going without it is like trying to paint a picture while blindfolded. And it's especially important for analog circuit design because every little subtlety in the voltage across your circuit is significant to some degree to the whole circuit. Noise is far less acceptable in analog circuitry because it's not being quantized based on a threshold. And defects are incredibly hard to spot without seeing the graph on the scope. Even if you could find it without it, it would be even harder to determine what is causing it and how to fix it. You can get these fairly inexpensively these days. Digital scopes are the most popular and also the only ones that are made anymore. The biggest features that set them apart from their analog counterparts are the ability to take snapshots internally, record the voltage over a period of time, do complex math on the waveforms, and do FFT spectrum analysis, and that is fast Fourier transform. And these are the features you really want to look for in a digital scope. You want a 100 megahertz bandwidth, general ballpark, more or less is okay. You can get by with a lot less in the analog world, but digital, you want to have a fair margin there. And you want the sampling rate to be at least 10 times the bandwidth. So for a 100 megahertz scope, that would be 1 gigasamples per second. And that way, you don't even approach the Nyquist frequency, and you won't have an issue with weird things going on with the scope. You want a minimum of 2 channels. You want 10x scope probes. And what those do is they attenuate the signal by a factor of 10. And they also greatly increase the impedance that the scope probes put in the circuit. So it causes them to be a much smaller load on your circuit. That way, if you're working on some fairly high impedance stuff, you'll know that your scope probes aren't going to introduce too much weirdness there between activity of the circuit while measuring and while not measuring. And I would recommend that the time scale can go down to at least 100 nanoseconds per division, and for voltage, at least 0.1 millivolts per division. And these are kind of ballpark round numbers. They might not matter too much for your application. I'm just describing what I would like to see in something that I would look for. The ability to take a snapshot, which I don't know if any digital scope doesn't have that, but I would just make sure it has it because that's the biggest reason I would want one myself. And then preferably one with a high frame rate, so it doesn't look like the frame updates every half a second. You really can't beat the responsiveness of an analog scope, and so I would just try to get as close as possible. Anything else feels a little bit frustrating in my experience, or in my opinion. But analog scopes are still quite capable and can be had for low prices on the used market as well, for a basic one. But you will go without built-in snapshots and FFT. Mine is a Tektronix 2467, which is right behind me. And it's a 350 megahertz analog oscilloscope. And I got it for $400 on eBay in like new condition, and it's the one that I use for everything. It has a few bells and whistles like time and voltage based display on the CRT and time and voltage measurement using on-screen cursors, thanks to a digital brain working alongside the analog parts. But my first scope was a BK Precision 30 megahertz analog oscilloscope without any extra features. And it got the job done and still does as my secondary scope. I got it for around 50 bucks on eBay and bought the probes separately. It didn't come with any. Of course it was used, and it was well worth it. Number 4, breadboards. These are a beginner's best friend. You'll need these to test out your design ideas and to reconfigure and troubleshoot them until you work out the bugs. They don't have a lot of current carrying capacity, and they have lots of parasitic capacitance and inductance, making them terrible for developing high power or high frequency circuits. But in my experience, they're indispensable for learning by doing. Especially in the analog world where each connection is more than just a logic 1 or 0, and the behavior of the circuit in any given configuration is so much more complex. But breadboards are great for developing anything low power and low frequency. I'd say a safe maximum frequency for a breadboard is around 100 kilohertz, and that can be pushing it in some cases. Audio frequency, on the other hand, is no problem. That only goes up to about 20-25 kilohertz, depending on what margin you want to leave there. And this is one thing you definitely can't cheap out on. I've personally chased issues down to a low quality breadboard after several minutes to hours, thinking I made a mistake somewhere in my design. Cheap breadboards are usually too loose, too tight, both in the same unit, and low quality conductor which oxidizes over time. I know that $9 Elegoo 3-pack looks promising on Amazon, but don't fall for it. And to be clear, Elegoo does make great cheap stuff, but their breadboards, I wouldn't buy any more of them. They're not particularly great, but $9 is what you should be spending on a single breadboard. I recommend the brand called Busboard, which is available on Amazon as well and costs close to $9 for an 830 point unit, aptly called the BB830. And it's well worth it. The quality is terrific. And you can't have too many breadboards, so I recommend throwing 1 or 2 in every electronics haul that you make, especially if you can't just buy 10 or 20 at once, which would be what you'd want to do if you want to stock up. Number 5 is jumper wires and hookup wires. I recommend multicolored assortments of solid core wires and stranded wires for breadboard jumpers and general purpose hookup wire, respectively. I'd go for 22 to 24 AWG stranded wire and 22 AWG solid wire. And that's AWG is American wire gauge. There are many different types of wire you could get, but realistically, you'll get by just fine with those 2 when starting out, or even much farther than starting out. You can get tinned or non-tinned wire, but just make sure that it is copper wire and not copper clad aluminum, abbreviated as CCA. A lot of cheap, too good to be true prices on Amazon want you to think you're getting copper wire when they're actually selling copper clad aluminum. So just be sure that CCA, copper clad aluminum, isn't anywhere in the listing, because the listings in my experience won't outright lie to you, but they can be misleading. I have bought some CCA wire before thinking it was copper, and it wasn't a big deal for my use case, but just be aware. You want copper wire for your hookup wire. And of course, you'll need wire strippers to go with the wire, and I recommend the automatic type. They just make things go faster. But the regular electrician's type work just as well. And I custom make all of my breadboard jumpers by stripping just about 3/8 of an inch off each end of an appropriate length of solid wire. You can also use the pre-made jumpers, but most of them are crimped and quite a fine gauge wire. At least the ones I have are cheap, so I hardly use them and I don't buy any more. You can make stranded jumpers using stranded wire, pin headers, and heat shrink tubing, but they don't usually offer an advantage over the solid jumpers, and the solid ones are quicker to produce. And where the stranded wires will really shine is when you take your circuit from the breadboard to a permanent solution, whether it be a perf board or a full-on PCB. You'll need wire to hook up the different things in your circuit that aren't soldered directly to the board, hence the nomenclature hookup wire. Number 6, clamp leads. While we're in the vein of wires, you'll also need the ability to quickly make connections where there's no proper way to do it. Quick and dirty, as they say. These are things which you also can't have too many of, and you want more than one type. Alligator clips are the most common, and you should definitely have some, but there are other less clumsy types for making connections in tighter spaces or to smaller or more delicate things. I really like hook clips. They fill that need pretty well. I find that connecting things such as a power supply to a circuit on a breadboard is really simple and not cumbersome when I use those. And while these aren't quite clips, I'll also throw in banana plug wires. I use them to hook up my power supply and one of my multimeters with hook clips on the other ends of them. So in a sense, the ones I have are a form of clip, but in general, banana plug wires are just great to have. And it's another thing you don't want to go too cheap on. However, these are quite cheap anyway as they are. Just don't buy the cheapest ones you can find. I've had to repair my alligator clips before because the crimped connection failed. It had me thinking there was another problem somewhere else until I tested the continuity of the wire from clip to clip. So I ended up soldering the connections and haven't had an issue with those specific wires since. A common thread here is that you need your development and test equipment to be reliable so that when you're troubleshooting issues, you know the issue is really in your circuit and not the equipment which you're using to test it. Number 7, discrete components. Resistors, capacitors, transistors, diodes, and even inductors. You'll need to make sure you're well stocked so you don't run into supply issues when an idea hits, or when a problem can be solved if only you had the right component on hand. My recommendation is to buy assorted kits of resistors, capacitors, inductors, and diodes. You probably won't use many inductors, but they're good to keep on hand anyway. And then I would get larger quantities of the components which are most commonly used. So for example, your 1K resistors, your 10K resistors, 1 microfarad ceramic capacitors, 1N4007 diodes, etc. I have drawers and drawers of commonly used component values, as well as lots of reels of SMD variants. And when shopping for your resistor kits, look for 1% tolerance. I don't bother with anything of a higher tolerance than that, largely because 1% is cheap and it makes sure that there's a very small margin of error. And then I'd look for 1/4 watt, 1/2 watt, and 1 watt kits of those resistors. 1/4 watt will be what you use most of the time, but there will be times you'll want something that can dissipate a little bit more heat, and so the 1/2 watt and 1 watt kits will come in handy there, especially when you need to use a low value resistor. Also, still look for 1% even when shopping for your larger quantities of common values. And for your capacitors, tolerances aren't as tight, so anything 20% or below is acceptable for what ceramic capacitors are really used for. On top of that, you want a voltage rating of at least 50 volts for ceramics. Electrolytics come in various sizes, so it isn't quite as important when shopping for a kit to be concerned about the specific ratings. But be mindful of the rated equivalent series resistance, or ESR, on electrolytic capacitors. The lower, the better. It basically just means less power is wasted when charging and discharging them, and they generate less heat as a result. And they can charge and discharge faster because there's less resistance in the way of them internal. Now the cheap ones usually have higher ESR, which will get you by as a beginner, but if you can find a kit with, say, sub 1 ohm or even sub milliohm ESR, go for that one. And as far as transistors go, get decent quantities of these ones in particular. 2N3904 NPN BJTs, and BJT is bipolar junction transistor. 2N3906 PNP BJTs. These are going to be your most common general purpose transistors, and there are some other ones, but these ones are extremely common. VN2222 N-channel MOSFET, metal oxide semiconductor field effect transistor. Most of us know what MOSFETs are, but a lot of us probably also don't know what the acronym actually means, and that's what it is. And the VN2222 is just a general purpose small signal MOSFET. You want to look for the IRFZ44N N-channel MOSFET, and this is a power MOSFET. And then a good complementary MOSFET to that one is the IRF5305 P-channel MOSFET. You'll use the N channels more often, but it's good to have something that's at least almost complementary. It's hard to have complementary MOSFETs in discrete form, but those two are pretty closely matched and you can use them as a complementary pair. And those last two come in a TO220 package, which you can use to switch larger loads because they're power MOSFETs. And those first three are low power transistors, which can be used anywhere they won't be required to conduct significant amounts of current. You want a few different diode kits as well. One general purpose kit of diodes with switching diodes, rectifier diodes, and Schottky diodes. One with various LEDs because those are light emitting diodes. And one with various Zener diodes. Zener diodes are the ones with a specific reverse bias breakdown voltage that can be used as a crude voltage regulator, overvoltage protection, or the basis for a more sophisticated regulator. And similar to the Zener diode is the TL431 voltage regulator. It's like a variable Zener diode with a third terminal to set the threshold. And it's actually an IC, an integrated circuit, but it's such a simple one, such a ubiquitous one, that I included it here because of how basic it is. It's much more accurate than a Zener diode and is used as the basis for very stable regulators and voltage references in general. That's what the TL431 is best at, being a voltage reference. It has an internal 2.5 volt reference, which can be used to program it to any voltage you want within its maximum ratings. It's definitely a staple in analog circuitry. And number 8, integrated circuits, or ICs. Unless you want to build every little thing from the basic building blocks and end up with a vastly inferior result, you'll need to pick up some ICs. The NE555 timer is a must. It's pretty much the first thing that gets recommended to beginners, and for good reason. You can learn a lot of basics using it, and you can use it in a lot of applications. You can use it to do so many cool things, but its use as an oscillator or time delay are at the top of the reasons you need it. It's trivial to set it up to do anything time related, and its time-tested ubiquity is a testament to its versatility. I used one as the basis for a multi-channel PWM LED strip dimmer. That was kind of a mouthful. Pulse width modulation is what PWM stands for. And using a constant current source and current mirror, I used it to generate a sawtooth wave instead of a square wave like usual. Now you also need some op amps and comparators. Comparators are like op amps, but optimized to flip much faster on a much smaller input difference to a high or low state on the output. Op amps are normally used to amplify differences between their inputs, but can be set up to do some other cool things as well, like integrators for hysteresis, or gyrators which convert capacitive reactance into inductive reactance. And linear voltage regulators are essential to having multiple voltage source levels in your circuit and regulating the voltage in your completed circuits once they're off the breadboard. You don't have to use linear regulators, but they're the simplest kind to set up, so the best for a beginner to start with. You can get them in non-configurable types or configurable. I recommend having both, but the non-configurable types will probably be used more often, since you'll most often be using standard voltage levels in your circuits. Number 9, user interface components. These will be your buttons, potentiometers, jacks, plugs, LEDs, etc. There are all kinds of things to get a hold of here, but you'll probably want things that are easy to connect to a breadboard and some that are easy to mount to a panel and wire to a PCB. So I'll let you decide exactly what you want to get, but don't go too cheap here. You'll end up with annoying issues like excessive bounce in the buttons, dead zones in the potentiometers, and poorly connecting jacks and plugs due to oxidation. You can probably find a kit of things online so you don't have to shop for all these things yourself, but I'll give you a list of things to consider picking up. Single pole double throw toggle switches, abbreviated as SPDT, double pole double throw toggle switches, DPDT, momentary push buttons, 5mm DC barrel jacks, male and female, 1K, 5K, 10K, 50K, and 100K potentiometers. Those will be your best general purpose ones. Knobs for your potentiometers. Make sure the knob type matches the type of shaft on your potentiometers, and if you get a kit, they will match. But if you're buying them separately, just make sure that if you have D-shaft potentiometers, you get the D-shaft knobs. Or if you have round shaft potentiometers, get the round shaft knobs with the set screw. You know, that kind of stuff. And then an assortment of LEDs, which we mentioned earlier. And number 10, soldering equipment. Once you're ready to go from the breadboard to something more permanent, you'll need to solder it all together. You want to pick up a soldering station, lead solder, helping hands, and start learning. Like I mentioned in the beginning of this video, I make lots of videos on soldering, and among them are my list of essential tools and tips for beginners. So go check those out to really get a grasp on what you'll need and what you'll need to know to get started. So if you found this video at all helpful, don't forget to hit the like button, subscribe, and hit the bell so you know when new videos come out. This is the place for videos on soldering, electronics, and electronics repair. I'll see you guys in the next one.